This is the second video in BC Calculus on power series. And so we're going to be looking at in this video how to go from function notation for a power series into sigma notation or series notation for a power series when it's not necessarily in our straightforward 1 minus r denominator format. So here, for example, we have the function 2 over x plus 4. We're looking for it to be of the format a over 1 minus r, specifically 1 minus. So if you look at the function 2 over x plus 4, first thing is I don't see any subtraction there, and our x needs to be part of the r. So one thing I could do is I could rewrite this as 2 over 4 plus x, or 2 over 4 minus negative x. So that at least gets my subtraction there in the denominator. But then I have the issue of the 4. I need the 4 to be a 1. Well, the way to get that 4 to be a 1 is to divide it by itself. But if I'm going to divide that by 4, I have to divide every other piece of my fraction there by 4. So this becomes a 1/2 in the numerator, and then 1 minus negative x over 4, which is not the normal way that you would write a function. You would write it as 2 over x plus 4. But this is the way I need the function to be written so that I can identify the a and I can identify the r. Looking at it this way, I know that a would be 1/2 and r would be negative x over 4. So my sigma notation then would be the sum from n equals 0 to infinity of a times r to the n. So there's your sigma notation. Now the next thing they want you to do is they want you to determine the interval of convergence for that. So remember, the way that the interval of convergence works is we take whatever the absolute value of r is, and we need it to be less than 1, which means that r needs to be between -1 and +1. So then we solve for x there. Multiply 4 to everything, so we get -4 is less than negative x is less than +4. And then hopefully you remember from way, way, way back when we divide by -1, that's going to flip our inequalities, and this will become a +4, and this will become a -4. Notice what that does, though. That just means that our interval is -4 is less than x is less than +4 if we read from right to left instead of left to right. But once again, with the interval of convergence, we have to check the endpoints of the interval to see if they would create a series that would converge or not with a common ratio less than 1. So we could start by checking x equals -4. If x was to equal -4, then that would make my sigma notation look like the sum from n equals 0 to infinity of 1/2 times -4 over 4 to the nth power. So that's going to change to the sum from n equals 0 to infinity of 1/2 times 1 to the n. R is then 1. I can't have an r of 1. It has to be less than 1. So this one would diverge. The same thing is going to happen with x equals +4. We'll have the sum from n equals 0 to infinity of 1/2 times 4 over 4 to the nth power. So again, our r is 1. And so that would diverge as well. So your interval of convergence is -4 to +4. So in terms of my answers to the problem, here is my power series. Here is my interval of convergence. So now we're going to look at another function that we want to write as a power series and determine the interval of convergence for. Now, one thing that was left off in these directions, though, is that we don't just want to determine a power series for this function, but I also want to specify what the center of my power series is. Power series are traditionally centered at x equals 0 unless otherwise specified, or unless the way that the function is written kind of lends its way to be centered somewhere else, or the way that the series notation was written lends itself to be centered somewhere else. So if it's a function notation and they want you to center it at anything other than x equals 0, they're going to tell you what to center it at. I just left it out of the directions here. So I want to determine a power series centered at 1. So if I have a power series centered at 1, then in that general formula for my power series, a times r to the n, I want that r to be x minus whatever my center is. So I want r to end up being x minus 1. So what that means is that I'm going to have to do some algebra trickery with this function from the very beginning to make that x not be just an x, but be an x minus 1. So how are we going to go about doing that? Well, let's say that I wanted that, instead of being 2 times x, I want it to be an x minus 1 right there. And then I would have the plus 1. Now, I have to be balanced, though, because I need what I just wrote down to be equivalent to 6 over 2x plus 1. Well, if you look at what I have written there in blue, if I was to distribute that out, I would have 2x minus 2 plus 1. That's not equivalent to 2x plus 1. So this is kind of like, you may remember when you did completing the square way back when in a very earlier class than this. Anything that you do to the inside, you have to balance it on the outside. So since this would equate to subtracting 2 in the first portion here, then I need to add 2 onto the end there to balance it out. So what that does is it gives me 6 over 2 times x minus 1 plus 3. So that's the first thing that you want to go about if you have a center other than 0, is you want to go about working that center notation in there. Then we still have the issue of it needs to be a over 1 minus r. So now I will rearrange that so that the r portion, or the x portion, is being subtracted. So this would be 3 minus negative 2 times x minus 1. So now I have it in subtraction form. And then I need that 3 to become a 1. So I need to divide this by 3, and this by 3, and this by 3. So that gives me 2 over 1 minus, now inside of here, you can write this as negative 2/3 times x minus 1. So I have a 1 minus, and I have x minus 1 as part of my radius of, or my common ratio there, my r value. So now I recognize that a is the numerator, and then r would be negative 2/3 times x minus 1, which means that the power series notation for this function would be n equals 0 to infinity of 2 times negative 2/3 times x minus 1 to the nth power. And so that's how you could write the power series notation for that function. Now, it's possible that they may do some simplifying and manipulation of that to write it in another way as a multiple choice answer choice, because of the fact that there are those 2's there, and because of the fact that you have a negative there. So just kind of follow along with me. I'm going to kind of think about that negative 2 and the fact that it's raised to the nth power. And in fact, all of this is raised to the nth power. If I kind of separate this, I would have a 2. And then instead of a negative 2, let's think of it as a negative 1 to the nth and a 2 to the nth and an x minus 1 to the nth and a 3 to the nth. So basically, I just distributed the nth power to all of the things inside of it that were being multiplied together, including splitting up that negative 2 into a negative 1 and a positive 2. Now, in doing so, that becomes the sum from n equals 0 to infinity of negative 1 to the nth. How many 2's, though, do I have in the numerator? It's not 2 to the nth anymore. It's 2 to the n plus 1, because we could add the exponent of that first 2 to the exponent of the 2 to the n. And then times x minus 1 to the nth over 3 to the nth. So that is possibly how they might write it in multiple choice form. But on an FRQ, any of these sigma notations are okay. This is perfectly okay for an FRQ for you to write it like that. Multiple choice may go this far, it may not. I'll be honest, if you're doing a multiple choice question and you can't find your answer in the answer choices and you're not sure how to simplify it, start with substituting in at whatever n begins equaling, write out some terms, and then just go through your answer choices and do that with those and see which ones match up to the same terms you would have. That's really the best thing I can tell you to do if the simplifying is difficult for you. Okay, so there's our power series. The next thing we then need to do is our interval of convergence. So everything that's inside that nth power makes your R. So that would be negative 2/3 times x minus 1. And I'm going to go ahead and jump to the compound inequality there, where it's between -1 and +1. So now to solve for x, we would start by dividing by negative 2/3. So that would flip this to a positive 3/2, but it would also flip the inequality. And this would flip to a negative 3/2, but we would flip the inequality. And then we add 1 to each of those. So if I add 1 to 3/2, I get 5/2. And if I add 1 to negative 3/2, I get negative 1/2. And then just because we don't write our intervals like that with the greater than signs, if we read it from right to left, it becomes negative 1/2 is less than x is less than 5/2 for your interval of convergence. And I'll go ahead and tell you, if you check your two endpoints, again, they're not going to work. You may be starting to figure out that the endpoints on these power series are never going to work because they're going to give you an R exactly equal to 1, which we can't have. So there's really no need to continue to check them if you recognize that. So there's your interval of convergence, negative 1/2 to 5/2. And that wraps up the first portion of power series.